the topic is coarse dispersion. Coarse dispersion means the particle size is 500 to 5000 nanometer. 500 to 5000 nanometer. This is a biphasic two-phase form. Biphasic means one phase is water, another phase is either oil in case of emulsion, oil in case of emulsion, solid in case of suspension. Like biphasic two-phase form. Examples are suspension and emulsions. Suspension nothing but dispersion of solid in liquid, emulsion nothing but dispersion of liquid in liquid. You can call as a emulsion. The whatever the coarse dispersion, whatever the coarse dispersion are there, the particle size 500 to 5000 nanometers are those particles are visible to our naked eye. These particle sizes are visible to our naked eye. So these are thermodynamically unstable. These are thermodynamically unstable means when you have prepared, see for example, you have prepared a suspension. If you have prepared a suspension and when you kept at rest, when you kept this suspension at rest, then the formation of sedimentation means all the particles settle at the bottom. At the rest, all the particles settle at the bottom. This is, we can call it thermodynamically unstable. This is, we can call it thermodynamically unstable. In emulsion also like this. But in emulsion, just merging of two drops means two oil droplets are just merge and leads to formation of a big oil droplet. We can call it as coalescence. But no settling of oil droplets at the bottom. Just combining of the two droplets lead to formation of big droplet. We can call it as a coalescence. In suspension, there is a settling of the particle. Due to high density, the particles will get settled at the bottom at rest. Then we can call it as thermodynamically unstable. So they reduce the surface of dispersed phase exposed to the continuous medium by coalescence or by sedimentation. See, whenever you have formulated the suspension, for example, these three particles are there. Each particle having more surface. See, you can measure the surface of this particle is more. Then, due to this more surface area, more surface energy is there. Means the particles having more surface energy. When the particles having more energy means these are always in the motion. These are always in the motion that leads to the particles are at higher energy state. Then they come to lower energy state by reducing their surfaces. See, when the particle, see this particle surface is this particle surface is this particle surface is this total. When I combine the two particles, there is a reduction, means there is a reduction of surface. There is a reduction of surface area. See, the surface present in between these two particles is merged. The surface present between these two particles is merged. Whenever the settling at bottom, see this surface area are not exposed. This surface area is not exposed to the medium, continuous medium. Whenever the surface area is reduced, surface energy also reduces. Whenever the surface area will reduce, surface energy also reduces. And the suspension becomes stable by reducing the surface area. The suspension becomes stable. So, but the sediment form of suspension we know it. See, for example, this sediment are just, you can consider as a drug particle. When you will take the suspension, the only liquid will come, but the particles get sedimented at the container. So this is disadvantage. So we need thermodynamically stable, but not thermodynamically unstable coarse dispersion. But naturally the suspension reduce their surface area by settling at the bottom. Same, the two oil droplets are there. more surface area, more energy, surface energy is there. They will reduce the surface energy by combining of two droplets. See, combining leads to the formation of big droplet. Leads to the formation of big droplet. Surface area is reduced, surface energy also reduced. Like this, these are the, in the nature itself, these suspension and emulsions are thermodynamically unstable. The suspension and emulsion are thermodynamically unstable because this having more surface area, more energy. So in order to reduce the energy of the entire system, in order to reduce the energy of entire system, the particles get sediment. The particles get sediment and leads to reduce the surface area also. Whenever this reduces the surface area, surface energy will reduce. The system becomes stable. The system becomes stable like this in emulsion also. Now the pharmacist, how the pharmacist can improve how the pharmacist can make this thermodynamically unstable coarse dispersion like suspension emulsion into the thermodynamically stable dispersion. Initially these are thermodynamically unstable, but a pharmacist need to solve that problem. What problem? That pharmacist need to convert the thermodynamically unstable suspension or emulsion into thermodynamically stable emulsion or suspension. How can we convert that into these are physically stable? We can thermodynamically unstable also called as physically unstable. How can we reduce? Means physically unstable means coalescence or sedimentation. Just formation of coalescence or sedimentation. We can call it as physically unstable. Coalescence and sedimentation we can call it as physically unstable. In order to reduce the coalescence and sedimentation by reducing the surface energy, means just reducing the surface energy means by reduction of surface area. The surface area of when you reduce the surface area of particles, then surface energy also reduces. That is one method. Second one is increasing the viscosity. See, this is particle, these are the particle. So for example, consider these are the particles. How can I make stable means how can I prevent the particle to get sediment at the bottom means just increasing the density. See, whenever I have increased the density of the continuous medium means the particles will not get sediment. At the bottom. And next one is application of stress, nothing but shaking. This is the dispersion. When you will shake the dispersion, means just application of stress to this system, then the particles will get redispersed. Whatever the particles, see, these are the sedimented particles. When you will shake this, then again converted into this form. Redispersing. Just upon applying of stress nothing but shaking. Shaking of the system leads to the formation of uniform distribution of the particles. Just redispersing or nothing but application of stress in order to redisperse. Application of stress means shaking in order to redisperse the system. Next one, increasing the viscosity, reducing the surface energy. These three methods, by using these three methods, we can convert the thermodynamically unstable form into the thermodynamically stable form or dosage form. Just by applying these three methods, reducing of surface energy, increasing the viscosity upon application of stress, shaking in order to redisperse the particle. So this is about the coarse dispersion.